Okay, section 3.1, solving linear systems by graphing. We're going to be talking about several different ways of solving linear systems in the coming days. Um, this is one way, graphing two lines and finding a point of intersection, basically. First of all, we got to discuss, what is a linear system, and hopefully these pictures here are kind of giving you a sense of what that is. You can see two equations that are labeled equation 1 and equation 2. You can see two lines that are intersecting in the bottom left-hand corner. Up in the top left corner, you see kind of three different situations that can occur, and then some word problems, and we're going to be getting to those later. So a system of two linear equations and two variables, x and y, it consists of two equations, and they typically look like the following. You have a number times x plus a number times y equals another number, and then a number times x plus another number times y equals another number. And a solution of a system of linear equations in two variables, it's an ordered pair. Okay, so what you're going to do is you're going to graph these two equations, and you're going to look, are they crossing? And if they are, that's the solution to the system of linear equations. And that's our goal for today. That's all I want you to be able to do is graph two lines and then tell me where they intersect, because where they intersect is where the solution is. Before we do that, we need to be able to check to see if an ordered pair is a solution. And so in this example, we want to check whether 2, 2 and 0, negative 1 are solutions to the following system. 3x minus 2y equals 2, and x plus 2y equals 6. Well, all we're really doing here is we're substituting. Remember, this is an ordered pair, x, y. And so for the first one, you're going to substitute it into the first equation. And so that'll be 3 times 2 minus 2 times 2 is equal to 2. And you're just going to do that math on the left-hand side of that equation. We know that 3 times 2 is 6, and 2 times 2 is 4. And we keep on going there. 6 minus 4 is 2. And so that checks out. But remember, this point has to be on both of your lines. So we have to check it in the second equation as well. So I'm going to substitute the 2, 2 into the x plus 2y equals 6. And that's what I did here. Now we do our math again. Remember to multiply before you add. So I'm going to do the black 2 times the red 2. We're going to get 2 plus 4, and the 2 plus 4 does make 6. And so since both of these came out with true statements, 2, 2 is a solution. Now let's check the point 0, negative 1. Again, we're going to substitute the values for x and y into our equation. 3x minus 2y equals 2. Then we're going to do our multiplying. 3 times 0 is 0. And then be careful with the minus 2 times negative 1. That's going to turn into a plus 2. Negative times a negative, a positive. And 0 plus 2 is 2. And 2 does equal 2. So that's checking out so far. But remember, it's important to check both equations. So we're going to go substitute the 0, negative 1 into x plus 2y equals 6. We're going to do our math here. The plus 2 times negative 1 is going to make 0 minus 2. And 0 minus 2 is negative 2. But negative 2 does not equal 6. And therefore 0, negative 1 is not a solution to this system of equations. And that's how you can check. And you're going to be expected to do that tomorrow. Now let's actually graph the linear system and estimate the solution. So there's, you can kind of see I've written two different ways of asking the same question here. Find a point of intersection and then estimate the solution. Those are two different ways of saying the same thing. So we're going to graph the red equation first, y equals 5x. And recall back to our last chapter what the slope and the y-intercept are of this equation. This equation has a slope of 5 and a y-intercept of 0. So we're going to put a point on 0. And then since the slope is 5, that means you're rising 5 units, you're running 1 unit, and 2 points make a line, so we drew our line. The blue equation has a slope of 1 and a y-intercept of 4. So we're going to put a point on 4, and then we're going to rise 1 and run 1. And you're going to notice I do this a couple times because it's important to be as accurate as possible when you draw your lines. And then again, you're looking for a point of intersection, and that's occurring here. So the solution is that whatever that ordered pair is, so it's 1, 5. X equals 1, y equals 5. Tell how many solutions the linear system has. Now, I'm not actually asking you what are the solutions, but tell me how many there are. And so it's the same idea. You're going to graph these. I've already provided you with their graphs because I just kind of wanted to go through this fairly quickly. But in this case, when you graph 3x minus 2y equals 6 and 6x minus 4y equals 12, they end up being the same line. And since they're the same line, they are always intersecting. And remember, a solution occurs where your two lines intersect. So if you're always intersecting, then there are infinitely many solutions. Conversely, if you graph your two lines and they never intersect because they're parallel, okay, well, if there's never an intersection, that means there's no solution. And that's going to be important to know. Okay, and I know there's a bunch of words up here and pictures, but what you need to know is that if the lines intersect at one point, there is one solution. If you graph your lines and it's a single line, meaning they're the same thing, one's right on top of the other, then there are infinitely many solutions. And if you graph the lines and they're parallel, that means there's no solution. And that's all you need to know for this section. You need to be able to check to see if an ordered pair is a solution by substituting it in, and you need to be, excuse me, be able to graph two lines and see where they intersect.